In today's lecture, the first topic of our discussion is determinants. We can find the determinant of every square matrix. That means this matrix having same number of rows and same number of columns. Now, every square matrix can be associated to a number, and that number is known as the determinant of that square matrix. Let us find how to find the value of a determinant of a square matrix of order 2. If A is a square matrix, then the determinant of A written like this, the determinant of A or A within this vertical bar, determinant of A is equal to the element of that matrix A11, A12, A21, A22, right? These elements as it was written in the given matrix A within the vertical bar, and its value will be the product of principal diagonal elements, that is A11, A22 with negative sign, A12, A21. So the determinant of a square matrix of order 2 is equal to the product of the diagonal elements minus the product of off-diagonal elements. These are called the principal diagonal elements and these are the off-diagonal elements. It may be noted that while matrix being just an arrangement of numbers has no values, the matrix are always the arrangement of numbers, it has no particular values, but its determinant is a scalar quantity having a definite value, and that value may be 0, it may be positive, or it may be negative. Now let us see with an example how we find the determinant of a square matrix of order 2. So this is 5, 4, minus 2, 3. Now find the determinant of this matrix. So it will be the product of principal diagonal elements, that is 5 into 3, 15, minus 4 into minus 2, that is plus 8, that is 23. Similarly, we can also find the determinant of this square matrix. It's product of the principal diagonal elements, that is cos A into cos A, minus sign, sin A into minus sin A, that is cos square A plus sin square A, that is equal to 1. So this way we can find the determinant of a matrix of order 2. Now let us see how we can find the determinant of a square matrix of order 3. That means a matrix having 3 rows and 3 columns. Suppose this is a matrix of order 3. Now the determinant of this square matrix, A denoted like this, determinant of A is equal to, write all the elements of the matrix and then within this vertical bar. Its value will be, if we are finding the value of the determinant corresponding to the first row, then write A11 and then exclude the corresponding row and corresponding column of A11, and then the determinant of the square matrix of order 2. That is, if we exclude the corresponding row and corresponding column of A11, then we are getting this sub matrix A22, A23, A32, A33. So the value of this determinant of this square matrix will be A22, A33 minus A32, A23. So A11 into the determinant of this square matrix, then negative sign A12, and then exclude the corresponding row, corresponding column. So we are having this submatrix A21, A23, A31, A33. So write the determinant value of that square matrix, and it will be A21, A33 minus A31, A23. Then with positive sign A13 into, now exclude the corresponding row, corresponding column of A13, then we are having the determinant of this submatrix A21, A22, A31, A32, and its value will be A21, A32 with minus sign, A22, A31. Clear? So the determinant the of a square matrix of order 3 is equal to minus 1 to the power 1 plus 1, I plus j. Here A11 is in the position of first to first column, so 1 plus 1, that is I plus j is 1 plus 1. This is positive, so here it is positive sign A11, and then the determinant of the submatrix after excluding the corresponding row, corresponding column of A11. Then plus minus 1 to the power I plus j A12. A12 is having a negative sign because of its location, because this is minus 1 to the power 1 plus 2. Its position is 1, 2. So I plus j is 1 plus 2, 3. 3 is odd, so it will have negative sign. And then A13. 13 is again, it is in the position of minus 1 to the power 1 plus 3, that is 4. This is even. So A13 will be of with positive sign. And then find the determinant after excluding the corresponding row and corresponding column of A13. Now comes to the minor in a square matrix. Minor, how we can find the minor of the element of any square matrix. The minor of the element Aij is denoted as capital Mij, and this is nothing but the determinant of the 2 by 2 matrix obtained after deleting the ith row and jth column in A. That means if we are finding the minor of the element A11, then just remove the corresponding row and corresponding column of A11 and find the determinant of the remaining submatrix. So the determinant of the remaining matrix is A22, A23, A32, A33. Its value will be A22, A33 minus of A23, A32. Okay. Similarly, if we are asked to find the minor of the element A22, then just delete the corresponding row and corresponding column of A22. So just remove this row and this column, and you are having this submatrix of order 2, that is A11, A13 and A31, A33. To find the determinant value, it will be A11, A33 minus sign A13, A31. And similar way, you can find the minor of each and every element of the given matrix A. The number of element in the matrix, whatever be the number of elements of the matrix A, we can find the minor of that every element of that matrix. Next, what is cofactor of the element in a square matrix? Now, the cofactor of the matrix is equal to minus 1 to the power I plus j into minor of the element in the determinant of that matrix. So, cofactor is related with the minor very closely. If we include the sign with the minor of that element, it will give the cofactor of that element. It means, suppose we are asked to find out the cofactor of the element A11. This is a square matrix of order 3. Now we are going to find out the cofactor of A11. The cofactor of A11 is denoted as capital A11. And this is equal to minus 1 to the power I plus j. Here I is 1, j is 1. So minus 1 to the power 1 plus 1 to mij. Mij is the minor of the element A11, that is M11. Since it is having the positive sign, if this is even, so it will be positive, and M11 is the determinant of A11 after excluding the corresponding row and corresponding column of A11. So its value is determinant A2223, A3233. If we are going to ask to find the cofactor of A12, it will be capital A12 and its value will be minus 1 to the power I plus j. Here I is 1, j is 2, 1 plus 2. And then the minor of A12, that is capital M12. Since this is 1 plus 2 odd, so it will be of negative sign. The cofactor of A12 is negative of M12, and M12 is the determinant after deleting the corresponding row and corresponding column of A12. If you exclude this row, this column, you will have the remaining submatrix A21, A23, A31, A33, and find the determinant value and you will get the cofactor A12. Similarly, you can find the cofactor A31, A32, and so on. Let us see. This is a given matrix, square matrix of order 3. Now find the cofactor of the elements 7, 8, 12, and so on. So the cofactor of 7, okay, it will be minus 1 to the power I plus j. Here its position is I is 2, j is 2, A22. So it will be minus 1 to the power 2 plus 2, and then the determinant of the remaining submatrix. If after deleting the corresponding row and corresponding column of 7. If you delete the corresponding row, corresponding column, you are having the submatrix 1, 4, 9, 12. So find the determinant value of 1, 4, 9, 12. It will be 12 minus 36. So it is even, so it is positive sign, and it is minus 24. Similarly, the cofactor of 8. The cofactor of 8. 8, its location first. Identify its location. This is second row, third column. So this is 8, 2, 3. So minus 1 to the power 2 plus 3, and then just delete the corresponding row of 8 corresponding column, and you are having the submatrix 1 to 9, 10. So find the determinant value of 1 to 9, 10. It's 10 minus 18. So this is minus 8, and it is already 2 plus 3. It is odd, so it will be negative sign. Negative of minus 8. So it will be positive 8. Similarly, the cofactor of 12, find the location. 8, 12, it is a 3, 3. So minus 1 to the power 3 plus 3. It is even, so it will be positive sign. And then the determinant of the remaining submatrix after deleting the corresponding row and corresponding column of 12. So delete this row, this column, and find the determinant value of 1, 2, 5, 7. It is 1 into 7, 7 minus 5 into 2, 10. So it will be negative minus 3. So this way we can find the cofactor of every element of the given matrix A. Next, what is adjoint of a square matrix? First, we need to understand what is the transpose of a matrix. A matrix obtained from the given matrix A by interchanging the rows with the columns or columns with the rows is called the transpose of the matrix, and it is denoted as A transpose or A dash. If we are having a matrix A of order 3 by 2, and it is 1 minus 2, 2, 0, 3 minus 1. It is first row, second row, third row. 3 rows, 2 columns, first column, this is second column. Now, if you write the rows into columns or columns into rows, that means if you write the rows 1 minus 5 as column, so 1 minus 5, 2, 0, second row into second column, 2, 0, 3 minus 1, it was third row, and write it in the form of column 3 minus 1. Then this matrix is the A dash or A transpose is the transpose of this matrix A. Now if a matrix is having the order 3 by 2, then its transpose matrix will be of order 2 by 3. In general, if a matrix is having ordered m by n, then A transpose or A dash will have the order n by m, because we are interchanging the rows into columns and column to rows, so its transpose will have just opposite order. Now come to this topic, that is adjoint of a square matrix. Again, if you are having a square matrix, if you are having a square matrix, then the adjoint of that square matrix denoted as adjoint of A is equal to the transpose of the cofactor matrix. We know that the cofactor of A1, small a11, is denoted as capital A11. This is the cofactor of A11. This is the cofactor of A12. This is the cofactor of A13. So in this way we can find the cofactor of every element of the given matrix. Now if you transpose this cofactor matrix, that means if you write the rows into columns, the second row into second column and third row into third column, you will get the transpose of the matrix A. Clear? So adjoint of a square matrix is the transpose of the cofactor matrix. This is the definition of adjoint of a square matrix. We need to study this adjoint of a square matrix to find the inverse of the matrix. Okay. So first, you find the adjoint of the matrix A. To find the adjoint of the matrix, first step is you have to find the cofactor of every element. Now first write the cofactor of the element 1. The cofactor of 1 is denoted as capital A11 and its value will be its location, that is -1 to the power I plus j, that is 1 plus 1, and then the determinant of the remaining submatrix, that is the determinant of the matrix 4, 5, -6, -7, after excluding the corresponding row and corresponding column of 1. So its value will come out as 2. This is 1 plus 1, 2, even, so it will have positive sign. The cofactor of 0, now identify its location, it is A12, so its sign will be -1 to the power 1 plus 2, I plus j, that is 1 plus 2. So this is negative, this is odd, so it will be negative, so negative sign. And the minor of the element A, 0. That means now exclude the corresponding row and corresponding column and then find the determinant value. That is 3 minus 7 minus 5 into 0. So that is equal to 21. Similarly, the cofactor of A13, cofactor of -1 is -1 to the power 1 plus 3, and then exclude the corresponding rows and corresponding column of -1. Now find the determinant of the remaining submatrix of order 2, and its value will be 3 into -6 -4 into 0. So its value will be 6. And it will have negative sign because of its location. It is 2 plus 1, 3. This is odd, so it will have negative sign. Similarly, the cofactor of 4. Cofactor of 4. Just 4 is in the position A22, so its value will be -1 to the power 2 plus 2, and then exclude the corresponding row, corresponding column, and then find the determinant of the remaining terms 1 minus 1, 0, -7. So 1 into -7 minus sign 0. So it will be -7. In this way, we will find the cofactor of every element. Now, after finding the cofactors A11, 12, 13, A21, A22, A23, A31, A32, A33, write the values according to its position and then find the transpose of that cofactor matrix. And its value will be, the rows will become the columns. So A11, 12, 13 become A11, 12, 13, right? The rows in the form of column, and then second row in form of second column, and third row in the form of third column, and we'll get the adjoint of the given matrix A. Okay, thank you.